All right, well, hello, ladies and gentlemen. We're here with period 1. You want to say hi, period 1? No. Okay. So we're going to go over question 35 and 37 on the test review. So let's see what we've got here. We've got this balanced equation, and it says if we have 0.86 moles of hydrogen chloride, which is hydrochloric acid, which is going to be this one, if it completely reacts with calcium hydroxide, how many moles of water are produced? Okay, so this is what we're trying to find, moles of water. So I'm going to come up to the balanced equation, circle water. This is what we're trying to find. And I'm going to just put moles to remind myself that we're looking for moles. Okay, good. I haven't gone off the screen there. And it looks like our given is going to be 0.86 moles of hydrogen chloride, hydrochloric acid, hydrogen, and chlorine. It's this one right here. So this is our given. And we are given moles of that. And how convenient is this? We're doing a mole to mole. So in the world of stoichiometry, we're going to go from this to that. So all we got to do is put our given and multiply it by the mole ratio. So let's see. I'm going to go ahead and put our given over here. Does that make sense so far? Want to make it? Let me know because I can make mistakes. So we've got 0.86 moles of HCl, hydrochloric acid. That's our given, HCl. I'm going to put that over 1 on there. Okay. And now we need to. All we got to do now is multiply it by the mole ratio. Is it find over given or given over find? I'm sorry, what was it? You want the find over the given. Let's see. So we're trying to find, and look how convenient it is to have it labeled up here. We're trying to find water. How many moles of water do we have in that balanced equation? So we got 2 moles. So much enthusiasm. 2 moles of H2O. And then the given is HCl. How many moles of HCl do we have in that balanced equation? 2. Look how convenient it is if you annotate these and do that. So 2 moles of HCl, which makes sense because now I can diagonally cancel that. And since this is a 2 to 2 ratio, it reduces to 1 to 1. Oh my gosh, are you kidding me? Is it just 0.86 moles? Yeah. Is that our answer? Yeah. 0.86 moles of H2O would be necessary because these two are in the same ratio here. So, yeah, if we had whatever number of moles of HCl we'd get that same amount if there was no limiting. Well, that was pretty easy. Let's go to B now. So now we've got new givens and finds. If 35 grams of calcium hydroxide are completely reacted, okay, I'm going to take it, this is our given. So I'm going to go back up here. I'm going to erase these because those are the old ones. This is why it's really a good idea to use a pencil when you're doing stoichiometry. Let's see, so calcium hydroxide, that must be this one. This is our given. And we're at grams, are completely reacted. How many grams of calcium chloride? Calcium and chlorine. Okay, this is what we're trying to find over here. And we want grams. Okay, kind of a bummer because we've got to do a full grams mole ratio back to grams. We can't take any shortcuts, so we just got to do a full conversion there. So our given, 35 grams of calcium hydroxide. I'm going to the balanced equation, CaOH, and there's 2 of those, so that's going to be important when we do our molar mass, over 1. So let's see. Oh, we need to find the molar mass of calcium hydroxide because we need to have 1 mole of CaOH. Quantity 2 is how many grams of CaOH quantity 2. Group 1, could you help us out? How heavy is calcium when you look on your periodic tables? The rest of you get your periodic tables out. It's over here. How heavy is it? It's 40 grams, so we got 40. Okay, oxygen, we know that's almost by now, it's how heavy is oxygen? And we've got 2 of them, right? Because we got the print. So, okay, 32, 16 times 2 is, that's supposed to be a 40. And then we have 2 hydrogens. How heavy is the hydrogens going to be? 2, okay? So, what is 40 plus 32 plus 2? Can I have you? 74. We can agree it's 74? Yeah. Okay, so 74 grams will be 1 mole. This we diagonally cancel there. Now we've got to do, let's see, we're going grams to grams. We got to do our mole ratio. So we said it was the find over the given. We still centered on there. I don't want to go off script up there. Group 2, would you help us out? We're trying to find calcium chloride. How many moles of calcium chloride are in that balanced equation? There's 1 mole of CaCl2. And the given is CaOH. Group 3, could you help us out? How many moles of calcium hydroxide are in that balanced equation? Group 3? How many moles of calcium hydroxide are in that balanced equation? There's just 1. So 1-to-1 ratio. 1 mole of calcium dihydroxide. Okay, the moles of calcium dihydroxide cancel. That lets us know we set that up right. And let's see, the last thing we're going to grams. So 1 mole of calcium dihydroxide is going to be how many grams? Well, let's see. We know calcium was 40 from when we worked over here. How heavy is chlorine? Okay, so each one's 35. What's 35 times 2?
70.
What is 70 plus 40? Do you agree? Is that 110? So the molar mass is 110 grams of calcium chloride. Okay, moles of calcium chloride cancel there. All right, so let's see. Doesn't look like there's really anything it's too easy to divide. I mean, looking at these, I can tell that's roughly going to be a half. I think the answer is going to be about half of 110. Would you do your math? What is 35? Divide 74 times 110.
52.02.
All right, so you can do that. I'm not going to. Let's go to the next one. Did you get 52-ish?
Yeah.
Okay. And let's see, last one. Oh, don't want to cover up at the top. How many moles of CO2 will be produced? Oh, wrong question. How many moles of hydrochloric acid? Okay, how many moles? That's what we're trying to find. So I'm going to come back up here, erase this. We got new given and finds. We're trying to find hydrochloric acid, and we're trying to find moles of hydrochloric acid. Oh, that's kind of convenient. Moles of HCl. Okay. Oh, this is our find. And are needed to produce this much calcium chloride. This is our given. Calcium and chlorine, CaCl. Okay, CaCl2. This is our given now. And we're starting with grams. So we're starting with grams. We got to divide by the molar mass. Then we got to do the mole ratio, and I think we're done because we're just looking for moles. So it's kind of nice to have the big picture over there. So we're going to do 100 grams of CaCl2 over 1. And the molar mass, I think we already figured out the molar mass in the previous problem, didn't we? Is that 110 grams? Got to divide by 110 grams of calcium chloride is 1 mole of calcium chloride. Okay. And let's see, next is, let's see, lost track. We started there, we changed it into moles. Oh, now we got to do the mole ratio, which is the find over the given. Group 4, could you help us out? In our balanced equation up here, how many moles of HCl are there in that balanced equation?
2.
There's 2 moles. That's what we're trying to find. So 2 moles of HCl. And in our given, how many moles, group 5, do we have of our given, which was calcium chloride in the balanced equation?
1.
Just 1 mole. Yeah, since there's no number in front, no coefficient, it's just 1. And you know, if it helps you out to put a 1 in front of it, you can. We got 1 mole of calcium chloride. Now let's see, if I set it up right, that will cancel there. Moles of calcium chloride will cancel with moles of calcium chloride. So basically it's 200 divided by 110. Can you do your math magic out there? And what did you all guess? 200 divided, it's going to be a little less than what?
1.81.
Little bit.
1.81.
1.81?
Yeah.
Is that about right, everybody? Okay. So I'm going to stop this right here because this is going long. I'll finish that later. So goodbye, everybody. Thanks for being such an awesome audience.
Bye, Mr. Gibbs.